What? You want more interval of convergence? Of course you do. All right, let's jump into this one. In this video, what we're going to see is that we actually have to test endpoints when we find the interval of convergence. Let's dive and see what this is all about. So this says find the interval and radius of convergence for that. Now, in terms of looking for the interval and radius convergence for this thing, what we got to recognize is we're going to start out with our limit as n goes to infinity, our ratio test, of the a sub n plus 1 term, the n plus first term. So we plug in n plus 1, x to the n plus 1 over n plus 1 squared. So we get that. Then we're going to multiply that by the reciprocal using the common ratio test here of the nth term. That'd be n squared over x to the n. And that is going to be less than 1, right? That's what's going to make this thing converge. So we do some simplifying here. Now notice that we're going to get the limit as n goes to infinity of the n terms are going to be, well, take them out, they're going to be positive. All n values start at 1 and are greater than 1 after that. So it's that limit. And we're going to then multiply that by, sorry, my computer is hiccuping. We're going to then multiply that by the absolute value of, you've got n plus 1 x's over n x's. That's one more x in the numerator than in the denominator. So we're going to end up with just x. Again, that's like x to the n times x. These divide out. And that needs to be less than 1. Now here's what's interesting. The limit as n goes to infinity, that limit only applies to the n terms. You have n squared over n squared, basically. This is going to go to 1. So you get 1 times the absolute value of x is less than 1. So the absolute value of x has to be less than 1. Oh, well, using a little bit of algebra, that means that the magnitude, the size of x, needs to be between 1 and negative 1. But that's not your interval of convergence. Oh no. We can write down what our radius is though. So the radius of convergence is the distance from the center to the outer edges in a circle, right? So the center of this polynomial is 0. How do we know that? Because it's not x plus 2 or x minus 1, it's centered at 0. And so the radius of convergence is going to be 1, right? From 0 to 1, that's the distance. Or you could look at it and say the diameter, if you will, the distance between 1 and negative 1 is 2. Divide the diameter by 2 and you get 1. So that's equal to 1. I gotta be careful there to pull down the right finger, of course. I just thought of that. That would have been terrible. Okay, so anyway, you come here to do calculus and I give you the finger. That's just not right. Anyway, let's get back on track here. We gotta test our endpoints. And so anytime you get values that are finite endpoints, I like to write down test endpoints, and it's very simple to do. Our question is, does this series converge at negative 1 and at 1? We know it converges between them, but what about at them? So I would just write down x equals negative 1. And to do this, you're just plugging in negative 1 in for x. So that's negative 1 to the n over n squared. This is why you learned all of your power series rules of, not your power series, but all your series of convergence rules. All right, so now we're looking at this and thinking, wait a second. This is an alternating series with terms that decrease in absolute value to 0. Or you could say it's a converging p series. So I would say this equals a converging p series. Now it's kind of up to you whether or not you want to go formal about it. Some teachers want you to do that. If I'm taking the BC exam, I would write it's a converging p series because p is greater than 1. All right, so that's converging p series. That's enough evidence though to say that we'd include negative 1. We converge at that endpoint. We'll test it at x equals 1. So that would be from n equals 1 to infinity. To test the endpoint again, you just plug 1 into x. That's 1 over n squared. And so that is equal to, again, a converging p series. Right now here, I guess technically looking at this last one, I don't know that I would necessarily call that a converging p series. Looking at this previous one, you could say it absolutely converges because it's a converging p series. Or you could say, as I said, that it's an alternating converging series. Terms decrease in absolute value to 0. Either way, both of the endpoints when plugged into the power series converge. So that would be your interval of convergence, and this would be your radius. Not bad. So the radius you can find without testing endpoints, but the interval, we know between negative 1 and 1 yields an inequality of less than 1, but at those endpoints, we have to check them. Now, why do we have to check them? Because the ratio test is inconclusive when we are equal to 1. So we have to see what happens when we're equal to the values that give us that 1. That's why we got to test those endpoints. All right, let's do more practice. So it says find the interval and radius of convergence for this. Okay, so here's our nth term. Again, I go through and I take the limit as n goes to infinity, maybe beyond, maybe not, of the n plus first term. So that would be, well, the absolute value of x over 3 plus 2 all raised, this is going to be interesting, to the n plus 1 times, I guess we could just put it over n, 1 over x over 3 plus 2 to the n. And you might be like, how in the wide world of sports am I ever going to figure this thing out? Well, it's kind of an interesting one. I think it's kind of an interesting one. So what we've got here is, it looks really nasty, but it's not as bad as you think. Because x over 3 plus 2 is the same as this. You have one more x over 3 plus 2 here, that should all be less than 1, here, than you do here. So this is going to divide out with this perfectly, leaving you with 1 x over 3 plus 2, all in absolute values. Oh, there is no limit as we go to infinity. It's just going to be 1 because there's no n value left over. So I disregard the limit. Now, looking at this, the absolute value then, careful not to say, oh, my radius of convergence is therefore 1. It's not. We've got to get x alone before you can determine what your radius of convergence is. So we know we're going to be between 1 and negative 1. And I'll subtract 2 from both sides. It's negative 3. And subtract 2 is going to be negative 1. Not so bad. And now I multiply both sides by 3. It's negative 9 is less than x is less than negative 3. So our radius of convergence, if you look at this, well, the distance between these two things is 6 divided by 2. So your radius of convergence, I'll call it the ROC, is equal to 3, right? The diameter, if you will, there's no such thing as a diameter of convergence, but if there was, it'd be 6. Divided by 2 is 3. So there's your radius of convergence. We got that. Now we have to test the endpoints. So we'll do that here. Test the endpoints. Remember, the ratio test only tells you that if you're less than 1, not or equal to 1. And if we plugged in these values here into this, we'd be equal to 1. So we're going to test our endpoints. Let's start with the left-hand endpoint, negative 9. All we do is plug it into this series right here. So that'd be sigma from n equals, I don't know, I guess we're starting at n equals 1 right here to infinity. If I plug in negative 9, I get negative 9 over 3 is negative 3 plus 2 is negative 1. Ooh, this one is diverging. It diverges by the nth term divergence test, by the nth term test. Why? Well, if you take the limit as n goes to infinity of this, you're not going to get 0. And because of that, continuously alternates forever, this diverges. So that means that in our interval, we're not going to include negative 9. Let's check negative 3. So at x equals negative 3, we would get sigma from n equals 1 to infinity. If I plug in negative 3 over 3 is negative 1 plus 2 is 1 to the n. Well, that, by the same token, diverges by the nth term divergence test. Huh. Why is that? Well, if I take the nth term test of this, the limit does not equal 0, and so neither of these are going to be included. Okay, therefore this is your interval of convergence. We do not include the endpoints. Now, if I plugged in something like, pick negative 4. Plugging in negative 4 gives you negative 4 over 3, which is negative 4/3 plus 2 is 2/3. And 2/3 to the n is a converging geometric series. So we see that all the values in this interval lead to a converging series, but the endpoints and things outside of them make the series diverge. So only these x values work in this series to make it converge. I think it's pretty cool. I don't know. That's on you to see if it's cool or not. It's pretty neat though. Okay, find the interval of convergence of this thing. It's interesting. This will be the last one we do in this video. So to find the interval and radius of convergence of it, we're going to, again, use the ratio test. So the limit as n goes to infinity of the absolute value of the n plus first term, oh my goodness, all over the nth term. That'd be n factorial times x to the n. And that needs to be strictly less than 1. Okay, now here's the thing. The x to the n plus 1 and the x to the n, they will divide out. And you'll be left with just x, because you have one more x up here. Again, that's x to the n times x. They divide out. Now, that leaves me with the limit as n goes to infinity of, let's check this out. N plus 1 factorial is the same as n plus 1 times n factorial, so they divide out. Leaving you with the limit as n goes to infinity of, n plus 1 times the absolute value of the x that's left up there. Now, before we go on, this goes to infinity times the absolute value of x. X is going to be really, really, really big, or really, really small. But the product's going to be really, really big, except the only time this would converge is if x was 0. If it was 0 right here, before we took a limit, 0 times a constant is 0, and the limit as n goes to infinity of 0 is 0. That's the only value that's going to get you less than 1. Every other x value plugged in here, then multiplied by infinity, is going to get you to a number far more than 1. Therefore, the radius of convergence, the ROC, is 0, and the interval of convergence is equal to 0, meaning the only number that works here is if we plugged in a 0. Because 0 times anything is 0, and if you keep adding zeros, it's eventually, hopefully, going to be 0. So there's really, essentially, no radius of convergence. The interval of convergence is 0. It's pretty much useless. I wanted to go over that one because sometimes professors and teachers throw that one out there. You're not going to see something like that. Likely not like that on the BC exam. I've never seen it. And I know it like the back of my hand. All right. I will see you next time. Geometric series convergence. Till then, peace.